Hello, Mr. Minnick here, helping my students with string comparison worksheet number 1. Unfortunately, in Java, unlike Python and perhaps other computer languages, you cannot simply compare two string variables with a less than symbol. So for example, if you have a variable called x that's equal to, say, Bob, and you have a string variable equal to y that's equal to Zorro, and you wanted to know which string is alphabetically less than the other one, you cannot just go do something like if x less than y, and then do something based on that if statement being true or false. You cannot use the less than symbol with two string variables. Just can't do it. It's illegal. It will give you a compile error. So according to the AP curriculum and what we're studying here in this introductory course, we must use the compare to method that comes from the string class. There's also an overloaded equals method, an overridden equals method, I should correctly say, that is available for use from the string class, but we may or may not talk about that in this video. Let's focus on the compare to method first. Here's how the compare to method works. It takes the two strings in question and compares them on a character by character, letter by letter basis. So in exercise 1, we have the string literal Jane. And the first letter of Jane is obviously an uppercase J. And we're comparing it with the string literal Fred, which begins with an uppercase F. Now, any librarian or anybody that's looking at their iPhone contact list knows that Fred is alphabetically less than Jane. But a computer just doesn't know that from sight observation of two strings. The computer mechanically, when using the compare to method in Java, it evaluates each letter against the letter of the other string, and in this case, the J is compared against the F. But how's the J actually compared behind the scenes? Well, the computer goes to the universal ASCII chart. Sometimes we call it the Unicode chart, and it finds the decimal value, the ASCII value, we say, for an uppercase J. Here we go. It's the number 74. The decimal ASCII value for uppercase J is 74. Ignore all the other hexadecimal octal information that's found here at ASCIItable.com or any other place where you would find this information online. And just know that it's 74. The number 74 is what the computer thinks of as an uppercase J. And that 74 now needs to be compared against the ASCII value for uppercase F, which I see the ASCII value for uppercase F is, according to this chart, 70. See, 70 uppercase F. So 70 and 74 are being compared. Well, the way the compare to method works is that behind the scenes it subtracts those two in that order, 74 minus 70, and that difference is positive 4. So the difference, the subtraction, is a positive number. Specifically, it's the number 4, but we don't really care, generally speaking, how big of a positive number that is. So in this worksheet, either put a plus sign here or just maybe the abbreviation POS or write the word positive. For number 1, the answer is positive number. A positive number is returned from the compare to method. The compare to method returns an int. And the question is it a positive number, the number 0, or is it a negative number? Well, let's go with, let's evaluate the exercise number 2. Student over here to my right, Derek, please go look up the ASCII value for an uppercase Z. Jack, please look up the ASCII value for lowercase a and get back to me. Serafina, look up the lowercase a. Please, Nick, look up the ASCII value for lowercase p, and Stephen, look up the lowercase value, the ASCII value for lowercase d. Okay, as the teacher now, I'm going to go back around the room. Derek, what did you find for an uppercase Z? Quick answers, please. Uppercase Z. Okay, lowercase a, Jack. 97, Jack said. I'll come back to Derek with his uppercase Z later. Serafina, lowercase a. Good. Lowercase p. Nick? Come on, lowercase p. Lowercase p. 112. So let's do exercise 4 right now since we have these two numbers. Since the first letter in aardvark is tied with the first letter in apple, the second characters are being used by the compare to method. And 97 minus 112 surely comes out to a negative number. I don't really care what that value is, whether it's negative 115 or not. It's a negative value. That's all I care about. Now, number 3, going backwards here, those are the same string literals, IBM and IBM. So you end up with like nothingness minus nothingness, which is 0. In other words, I minus I, B minus B, M minus M, it's 0. 0 is a legal value that's returned from the compare to method. And back up to number 2. What's the ASCII value for uppercase Z, Derek? 90. 90 minus the 97 from lowercase a here is negative 7. We don't really care how negative it is. The answer to number 2 is neg. Back to number 5. Now, if Java runs out of letters and all those letters were directly compared to the JAVA of Java doc, we're left with sort of nothingness here, or 0, I guess, if you will, minus the lowercase d. Stephen, what's lowercase d? 100. And 0 minus 100 is negative 100, and it's definitely a negative number. So the moral of the story is, from exercises 1 through 5, Jane is not less than Fred. Because that's a positive number, you know that Jane is greater than Fred. Zebra with a capital Z is actually surprisingly less than apple with a lowercase a, unless you change the uppercase C to lowercase z, it would be alphabetically less than. And IBM is equal to IBM, and aardvark is greater than, even though it has more letters in it, that second A is less than the second P. Never go by the length of a string when using compare to. The length has nothing to do with it directly. Although in the number 5, the overall aardvark is less than apple, and Java is less than Javadoc, even though its length is shorter. It's less than because the nothingness at the end of Java is minus the lowercase d would yield a negative 100. So that's why it's considered overall less than. So now let's apply this information about how the compare to method works with an answer to number 6. Number 6, you're supposed to write an if statement, and you're supposed to know that it makes use of the compare to method. That would be something that on the AP exam you need to know, or just as an honors Java student, you should always know that Java has a built-in string class compare to method. And this if statement will need curly braces and parentheses. So we're supposed to compare the variable name with the string value Melanie. Well, we do that by applying the compare to method after the dot operator with a capital T in compare to. And we'll slap Melanie, the string literal value, right in as a parameter to the compare to method. And that simplifies to a number, either positive, negative, or 0. And to know whether name, see, we don't know whether name is Bob or Zorro. So the B might be less than the M, but the first letter of name, Z, might be greater than M. We don't know. So we check to see if that subtraction of the ASCII values behind the scenes is greater than or less than 0. And I typically just throw in greater than 0. If it's greater than 0, that means that name is alphabetically greater than Melanie. So it's like Nancy or Paul or some other letter like Robert that's after M in the alphabet. So if you threw a greater than 0 in there, then you would say system out println, according to the directions of this assignment. That's the phrase you're supposed to print out. Let's indent that for good style. You don't need all that extra space there. Now, another equivalent way to answer number 6 minimally is to say less than 0. But if that's less than 0, then name is alphabetically less than Melanie, but we want to print out the phrase greater than only if it's greater than. So we would need to throw a not in front of all this with the logical not operator from Java. So this is also an answer, putting the not with an extra set of parentheses there, but then having less than 0. I like the simpler version that we had a second ago because it's just cleaner and easier to understand. There may be other variations of answers here that I'd find acceptable for full credit, or that might be like multiple choice, right or wrong answers on the AP exam. But I think that's the cleanest answer right there for that question on this worksheet. Number 7, I'll let you do that one on your own time. And number 7, keep in mind that the OR word in English translates to this operator in Java. And it just looks like it's similar, but we're throwing some nots in here, some ORs, and you still have to write an if statement that gets across the correct logic and syntax. And number 8, sometimes when you declare a string variable at the top of a program, you set it equal to something like John, or even the empty string. But when you're not setting it equal to null string, or empty string rather, null string to be safe, you could just type string name semicolon. Well, the act of setting it equal to the keyword null is the same as just putting a semicolon after the word name there. The reference name is equal to nothingness. Nothingness is even less than empty string. Like nothingness is nothingness. It doesn't even exist as an object if you set it equal to null. It's just a variable name that's been reserved and can't be used for another variable, perhaps like an int, that you might want to bring into existence later on in the program. You could not say int name equals 0 if you've already previously in your code used name as a string variable name. So this act of trying to use the equals method that you can read about in my lecture notes, that act of doing that is illegal. You would get what's called a null exception error. Read about it in my lecture notes, test it out in JGrasp or any IDE, but that is the error that you would get. This is sort of like a trick question, and I'm going to erase it all for people that are not watching the video. That was the answer that you should have given there for number 8, and have fun doing the rest of the worksheet, mostly just number 7. Have a great day. Here is one last look at the worksheet. And there's number 8 with no answer.